Hey guys, today we're starting the last unit of geometry, which is probability. So before we get started, let's go over a few symbols that are important to know. The first one is this like U shape, and that means union, and it stands for or. Then we have like the opposite of the U shape, and it stands for intersection, and it means and. So we're going to be talking about like the probability that different things happen. So the U would be that the probability that this or that happened, and then the intersection is the probability that both things happen at the same time. And then also too, this has to do with sets and different things as well, which we'll get into all of that. But we also have the complement here. So a to the c power, or a with an apostrophe. Those stand for the complement. It is the opposite of a. So for example, let's think about flipping flipping a coin, right? If a is that I flip a heads, a complement is that I flip a tails. So that's what the complement means. We also have some other terms here and now some formulas. So mutually exclusive means that events do not share outcomes. They cannot happen at the same time. So for example, flipping a heads or flipping a tails. I cannot flip a coin and it be both heads and tails. So those are mutually exclusive. The next one, not mutually exclusive, this means that they share an outcome. So for example, you as a student, you could be in geometry and you could also be in art class. Those are not mutually exclusive because you could be doing both at the same time. And then complementary, so that has to do with the complement, right? So it's the same idea as before. It just means that everything that is not what we initially wanted. So like the complement of being in geometry is everybody who's in any class besides geometry. Now, we're going to get started with sets. So right now what we have is a set for A. So A is the set of numbers 3, 4, 5, and 6. And then you've got set B here, and it's the set of numbers 3, 6, 9, and 12. So the first thing I want to find is the intersection. This is anything that's in A and B. So which ones do they have in common? What numbers? Well, they both have a 3. No 4 in B, no 5 in B, and a 6 is in both as well. So what I do is I just go through each number, right? 3 is in both, 4 is not, 5 is not, and 6 is in both. And so the set A intersect B is equal to 3, 6. Now, the next one asks for the union. This means everything that's in A or B. So really we combine both together. So A union B equals, and I'm just going to start by listing all of A. So 3, 4, 5, 6. And then I'm just going to list the things in B that I did not already list. So we already listed 3 and 6. So then we'll go 9, 12. And there's A union B. All right. Now, example 2. I have a set C here, and I have a set D, but now I have something new. It is a set U. So the set U is our universe. So we're not going to just assume that all numbers ever are what we're looking at here. We're just going to look at our universe as this set of numbers. So if I'm looking for C complement, that's everything that's not in C. I don't want every number in the world that's not in C. I just want every number that's in this universe that's not in C. So what I'm going to do to find C complement is I'm going to look. Okay, so -4 is in the universe and in C. -2 is in C. 0 is in C, and 2 is in C. So I went to the universe and I just checked off the ones that are in C. So C complement is every number I did not check. because it's everything that's not in C. So -3, -1, 1, 3, and 4. There is C complement. I'm going to do the same thing for D complement. So D complement is everything that's in the universe that's not in D. So that means I'm going to check off 1, 2, and 3 for D. And so it's everything else, -4, -3, -2, -1, 0, and 4. So everything we've done so far is just sets and focusing on sets of numbers. We also see sets like this in Venn diagrams as well. So here's a Venn diagram looking at 8th graders that study Spanish, French, and Mandarin. And if you don't know how a Venn diagram works, this circle right here is the Spanish circle. And then we've got this circle right here is the French circle. So everybody in the orange takes French. Everybody in the red takes Spanish. Oops. And now everybody in the yellow takes Mandarin. And anywhere where the colors overlap, that's how many people are in both groups. So how many students study Spanish? That's everybody in this red circle. So that's the 108 plus the 15 is also in the red circle, plus the 2 is also in the red circle. So 108 plus 15 plus 2 is 125 students. Next, how many students study only French? All right, so within the orange circle, we do have this 15 here, but notice that that 15 is in both the red and the orange circle. So that means those 15 students study both Spanish and French. So if I want students that only study French, that's going to be the 40 who are only in the orange circle. The next one says how many students study Spanish, French, and Mandarin, so all 3. Well, that would be right in here where all 3 colors overlap, and there's none. So there are 0 students that study all 3. And the last one, how many study none of these 3 languages? So just like before when we had a universe in sets, the universe for our Venn diagram is this box. So if I want to know people that don't fall into any category of the whatever's in our Venn diagram, they're going to be within the box but outside the circles. So that's those 35 students there. They don't study Spanish, French, or Mandarin. All right, example 4. What is the total number of possible outcomes for tossing a coin and spinning a spinner with 5 congruent sections numbered 1 to 5? All right, well, tossing a coin, we have 2 potential outcomes. You could get heads or tails. And spinning the spinner, we have 5 options. That is that you land on a 1, 2, 3, 4, or 5. So I could draw a diagram here and give every possible outcome that could happen. So I could either get heads or I could get tails. And then from there I could get the spinner of 5 for each of these. Like I could do any of the 1, 2, 3, 4, or 5, 1, 2, 3, 4, or 5. And so at the end, you can find your total number of outcomes by just counting the last branches. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the way this works is if you follow, I flip a heads and then I spin a 3. That's a potential outcome. I flip a tails and I spin a 1. It could be any of these. Now, without drawing a diagram, there is an easier way to find this. And to find the total number of outcomes, I multiply the number of outcomes of A, event A, so let's say that A is flipping the coin, times the number of outcomes of B. And let's say that B is the spinner. So my total number of outcomes here is, well, there's 2 ways to flip a coin, and there's 5 ways to do the spinner. That means 10 total outcomes. So it's much easier to just simplify and find your answer this way, but you can also make one of these diagrams as well.